Okay, let's go over this review for our test coming up over Unit 7, Part 1. So, just running through each of these questions little by little. The first thing says to name 3 minor arcs. Remember, minor arcs are less than halfway around the circle, and you only use 2 letters to name a minor arc. And we've got a bunch of them. We've got minor arc AB, minor arc BC, minor arc CD, minor arc DA, minor arc BD. And you may not have listed all of these, but as long as you understand that a minor arc is less than halfway around the circle and you only use 2 letters to name it. Okay, a semicircle is exactly halfway around a circle, and you use 3 letters to name it. So you've got semicircle ABC and semicircle ADC. And of course, you could always call this one CDA, and you could call this one CBA. Okay, a major arc is more than halfway around the circle, so ABD, DAC, which is the same thing as DBC, CDB. So a major arc is more than halfway around the circle, and you use 3 letters to name it. Central angles. These are angles whose vertex is at the center of the circle. So angle AGB is a central angle, and angle BGC is a central angle. As long as the vertex is at the center of the circle, then you've got yourself central angles. Okay. All right, here we were asked for the measures of some various arcs. So I know if this one's 180 and this one's 90, this one's going to be 90, which is what arc AE was asking about. Arc ED, I knew that was 50 because it's 180 from here to here, and 180 minus 130 makes the 50. DBA, I found by adding the 130 to the 90. BDA, I found by taking 360 minus this 90 that we didn't travel, but you could have done BDA by adding the 130 to the 50 to the 90. EAB, that's a semicircle, exactly halfway around, that's 180. And EBD, that's all the way around except for that 50, so EBD would be 360 minus 50, which makes 310. Hopefully you thought these were pretty simple. Okay, next I needed to figure out some things about this problem. So the first thing I did was I know that these 3 angles will all add to be 180 degrees because they make up half of the circle. So I set up the equation that the 15x plus 3 plus the 4x plus the 7x minus 5 is 180. I combine all my x's, which makes 26x. I combine the positive 3 and negative 5, which makes negative 2. And then I continue on and I solve this equation and I get x is 7. Once I know what x is, I can plug 7 into all these x's and figure out whatever else I need to know. So first thing it wanted to know was what's the measure of angle RPQ. So if we put 7 into this x, we take 15 times 7 plus 3, and that makes 108. Then it wanted to know the measure of angle QPM, so I put 7 in this x, and 4 times 7 is 28. Okay, the next 2 questions are very simple. It wants to know the area and the circumference of the circle, and it told us to leave our answer in terms of pi. So I used pi d for circumference. My diameter is 18, so 18 pi. I know if my diameter is 18, my radius is half that, so the radius is 9. So our area formula is pi r squared, so pi times 9 squared, and 9 squared makes 81, so 81 pi. Area is always in square units, so inches squared, and circumference is always just in whatever the units is. Very simple. Okay, number 14, same kind of question. And we can either use pi d or 2 pi r. I showed the 2 pi r, but you can use pi d. It's all the same. And area is pi times radius squared, so pi times 6 squared. So you should get 12 pi meters for circumference and 36 pi meters squared for area. Easy peasy lemon squeezy. Okay, let's move on. Okay, so next we start getting into arc lengths, finding the length of a certain arc, and we said to leave our answer in terms of pi. So it wants to know the length of arc AB. I know to go the short way around since it only used 2 letters, so I don't go the long way around because that would be a major arc and would require 3 letters. So AB is a minor arc, so I go the short way around. So I take how many degrees the arc is out of how many degrees in the whole circle, 360. What's the length of the arc, x, out of the length around the whole circle. And the word that talks about length around the whole circle is circumference. And so my circumference is 10 pi. And then I just cross multiply and divide. And I get approximately 3.3, or 3.3 repeating. Okay, number 16 is just like this. It wants to know the length of arc AB. So once again, I want to know the little guy. So how many degrees it is, 30, out of how many degrees in a whole circle, 360. What's the length of the arc, x, out of the length around the whole circle. And the length around the whole circle is called circumference, and the circumference is 20 pi. Once I get that, I cross multiply and divide, and voila, I get my answer of approximately 1.7 pi. And hopefully everybody knows where my 30 came from. I know that this is a semicircle, so this is 180 degrees from here to here, and if this piece is 150, this piece has to be the 30. Okay, this next one is a little more involved. You have to do a little more thinking. So let me show you the picture that I drew. It says Amber has a wheel that has a diameter of 19 inches. So I drew my wheel, I gave it a diameter of 19 inches, and it says the wheel is rolled along the ground for 2 feet. Through what central angle does the wheel rotate to the nearest tenth? Okay, so we're rolling this wheel along the ground for 2 feet. And up here, I converted 2 feet into inches because our diameter was in inches. So they're going to wheel this wheel along the ground for 2 feet, which is also known as 24 inches. Okay, so I'm going to set up a proportion, and this is how it looks. I want to know what angle is it making, what central angle is it making out of the 360 in the circle, and then I know the length that the wheel is rotating. The length is it's going this 2 feet or 24 inches out of the length around the whole circle. And the length around the whole circle is circumference, and the circumference is 19 pi. So it's like the 2 problems up above, except for this time we know the arc length, we know the length of the arc. What we don't know is that central angle. And then I cross multiply and divide, and I get that it's about 144.7 degrees. Okay, getting into area of a sector. This is almost identical to arc length, except for we use area instead of circumference. Okay, so if I want to know the area of sector AOB, I take how many degrees that arc is out of how many degrees in a whole circle, 360. What's the area of this piece, x, out of the area of the whole circle? So I had to figure out what the area of the whole circle is, and that's where my 20.25 pi came from. And then I cross multiply and divide, and I get my answer. So You're finding the area of this sector here, so you have to compare it to area of the circle. Whereas in these problems above, we were finding the length of this arc, so we had to compare it to the length around a circle, which is circumference. Okay, 19 is just like this. So I wanted to know what the area of sector AOB is. So I take how many degrees the arc is, which is 80. That's because this is a semicircle. If this one's 100, that would be 80. So how many degrees the arc is out of how many degrees in the whole circle. What's the area of this arc out of the area of the whole circle. And the area of the whole circle we get by pi r squared. And once I get that that's 36 pi, I cross multiply and divide. And my answer is 8 pi meters squared. Okay, number 20. Same kind of problem. I just actually had to draw a picture for this one. So it said find the area of a sector if the circle has a radius of 10. So I gave us a radius of 10. And the central angle measures 72 degrees. So I'm going to find the area of this sector right here. And since I'm finding area of the sector, I have to compare it to area of a circle, which is 100 pi. So how many degrees is the arc? 72 out of all the degrees in the circle, 360. What's the area of the sector compared to the area of the whole circle? 100 pi. Cross multiply divide. And you get an answer of 20 pi centimeters squared. Okay, ready to move on? So this next one, this is finding area of the slashed segment. So first I have to find the area of the whole sector, all of this. But that's going to be too much area. So I did need to know the area of the circle. So I start off with how many degrees is my sector? 90 out of how many degrees in the circle? What's the area of this whole sector? X out of the area in the whole circle? 36 pi. Cross multiply divide and you get 9 pi. Because this is too much area, that's way more area than I originally wanted to know, I need to find the area of this triangle and then subtract the 2. So, to find area of a triangle, we take 1/2 base times height. I know that this radius is 6, so that means this radius will be 6. So I'm going to take 1/2 of 6 times 6, and that makes 18. And so since all I want is this little slashed section up here, I have to subtract these two answers. So I'm going to take 9 pi minus 18. And then I just put that in the calculator, exactly how it looks. 9 pi minus 18. I round to the nearest tenth, and I get about 10.3 inches squared. Okay, these next ones. Number 22. This is a four-sided figure. I know all four angles add up to be 360, so then I add the ones they give me, and I subtract from 360. If you happen to not know what these four angles should add up to be, we can use the formula n minus 2 times 180. Since there's four sides, we would take 4 minus 2 times 180. 4 minus 2 is 2, and if I take 2 times 180, that makes 360. So if you don't know what the four angles add to be, then we can use this formula right here that tells us. So that's what I had to do for this next picture. This is a 1, 2, 3, 4, 5-sided figure. So I figured out what those angles add up to be by taking 5 minus 2 times 180. That makes 540. and then I added the angles that they gave me, and I subtract from my 540. And that makes 190 degrees. Okay, number 24. This wants to know what the exterior angles always add up to be. And the sum of all exterior angles is always 360 degrees, no matter what the shape. Okay, the next one wants to know only one interior and one exterior angle. I always like to find the exterior first, and we're talking about an octagon, so that's 8 sides. So if I want to find one exterior angle, I take what they all add to be, 360, and I divide by the number of sides. An octagon has 8 sides, and when you divide, you get 45. And then an interior angle and an exterior angle, those two angles always add to be 180 degrees with one another, no matter what the shape. So I just take 180 minus my 45, and I get 135. So as long as you know one of these answers, the other one will be 180 minus that, because an interior and an exterior angle are supplementary. They always add to be 180. If you happen to want to find the interior angle first, then you would use the formula n minus 2 times 180. That tells you what all the interior angles add to be. And if you only want to know one, then you would divide by how many sides the shape had, which is n. So these are the formulas that you use anytime you're given a regular polygon. The reason I didn't use this formula n minus 2 times 180 over n with this picture is because this is not a regular polygon. Not all these angles are the same, not all these sides are the same. So I just used n minus 2 times 180 to figure out what they should all add to be, and then add the ones they give you and subtract. But if all the angles are going to be the same, because it's a regular polygon, then I can just divide by the number of sides, and I can get my answer that way. Okay, 26. Let's go through this. We want to know what the probability of hitting this shaded ring would be. So I need to figure out the area of this ring and compare it to the area of the whole circle. So here's the area of my whole circle. So let's talk about that. It says that the center circle has a diameter of 4. So if this center circle here, let me cover this up for a minute. If this center circle has a diameter of 4, I know that its radius is 2. Okay, and so to figure out what the area of the whole circle is, I need to know the radius of the whole circle. So I add the 2 plus the 6 plus the 6, which makes 14. And so then I find that the area of the whole circle is 196 pi. Okay, so if I want to find the area of this shaded piece, I'm going to find the area of all of this, which is going to be too much, and then I'm going to subtract the little tiny circle. So here's my game plan. Find the area of this big inside circle here, which has a radius of 8, and subtract the inside circle, where there's no shading, which has a radius of 2. So that's what that game plan is. Find the area of this whole circle here in the inside and subtract the inside circle that doesn't have any shading. So when I do that, I get 64 pi minus 4 pi, which makes 60 pi. Okay, so if I want to know the probability of hitting the shaded ring, I have to take the area of this shaded piece out of the area of the whole circle, because my dart could land here or 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 here. So I take the area of my shaded piece that I just found, 60 pi, and I divide by the area of the whole circle, which is this 196 pi. And when I do that, I get a probability of about 0.31. I have about a 30% chance of hitting that shaded section. Okay, I hope that you are all prepared for this test, and I wish you all well and hope that you do awesome. Thank you.